Welcome to Azure Essentials. If you're an AWS professional, your knowledge on the AWS platform is going to make it easier to get started with Azure. Both are comprehensive cloud platforms, and in the next few minutes, I'll show you how key fundamentals of AWS translate to Azure. Like AWS, the Azure architecture gives you the flexibility to build solutions for both Windows and Linux. Both platforms also have a rich marketplace that supports a growing third-party ecosystem of apps and solutions. Some key differences when compared to AWS include the concept of accounts and subscriptions in Azure. In Azure, the account owner can delegate the task of managing subscriptions to application owners, which is important when the person paying the bills is not the person responsible for managing the technology. Also, imagine being able to run AWS services in your data center. With Azure, you can deploy Azure services in your data center using Azure Stack. And Azure also supports first-party hybrid integration between your cloud and on-premises solutions. Now let's take a look at core services across compute, storage, and management. Compute options are very similar between AWS and Azure. You'll find a similar range of on-demand virtual machine sizes in Azure to the EC2 instances in AWS, although you'll notice some differences in the memory, CPU, and storage options. Just as you'd create AWS instances in the AWS Management Console, you can create Azure VMs directly through the Azure portal using APIs or via the Azure command line interface for Windows or Linux. In both AWS and Azure, you can use auto-scaling to scale your application or service dynamically. In the case of Azure, you'll use VM scale sets to add or remove VMs automatically based on the metrics and thresholds you define. And where in AWS you have CloudFormation, you can use Azure Resource Manager or ARM templates to define your service or application architecture for multi-tiered workloads. Now, if you work with containers, in AWS you're probably working with the EC2 container service. In Azure, you'll want to use the Azure Container Service. Azure supports both Linux and Windows containers and a range of orchestration options, including Kubernetes, Mesosphere DCOS, and Docker Swarm. Additionally, the Azure Container Service also offers an easier way to run containerized applications, and Azure Container Instances let you rapidly create and launch containerized apps without any overhead and with an easily scriptable set of commands. Now moving on to options for serverless. To build and deploy serverless applications in AWS, you'll be working with AWS Lambda, the API Gateway, and other services. Whereas in Azure, you can accomplish the same with Azure Functions and other platform services. This includes Azure Logic Apps to model and automate your process workflows visually, and Azure's Database as a Service offerings. Lastly, Azure Service Fabric provides a runtime and services to build distributed, scalable, microservices-based applications. Going beyond compute, a persistent data store is at the heart of many applications, and Azure offers a range of storage options. If you work with S3 in AWS, in Azure you'll use blob storage. Like S3, you can use blob storage to store large amounts of unstructured data, either for private access or to share publicly. Now in AWS, you also have the option of cool storage using S3 standard IA, and Glacier for archival cold storage. In Azure, this maps to Azure Storage Standard Cool and Azure Archival Storage. The database offerings available through AWS and Azure are also similar, though there are important differences. Compared to Amazon RDS relational database options, in Azure you've got the choice of SQL database, Azure Database for MySQL, and PostgreSQL. Also, to create non-relational databases, Azure provides Cosmos DB. Cosmos DB is similar to DynamoDB in AWS with additional functionality, including SQL querying of unstructured data, low latency, and geo-replication. For traditional data warehousing, as provided in AWS with Redshift, Azure offers SQL Data Warehouse. Like Redshift, SQL Data Warehouse is a fast, fully managed petabyte-scale data warehouse. Now, if you're using Amazon EMR for big data analytics, including Hadoop, in Azure, you'd use HD Insights, which is a fully managed Hadoop offering. Additionally, Azure Data Lake Store allows you to store massive unstructured or structured data sets, enabling analysis of all of your data in one place. Now, moving on to our last topic, management. In AWS, you might start with the AWS Management Console and leverage CloudWatch, CloudTrail, X-Ray, and multiple third-party solutions. Whereas in Azure, the Azure portal gives you the consistent control panel from which to manage security, identity, apps, and resources. For custom troubleshooting, you can also use the Azure Cloud Shell, which supports both Bash for Linux and PowerShell for Windows from the browser. Through the portal, you can monitor metrics, logs, health, and the events of your applications, as well as your VM's utilization and other performance metrics. You can customize the Azure portal to build your own management dashboards and set up alerts to other devices and incident management systems. And where in AWS, you might then use a third-party analytics engine like Splunk. On Azure, you can continue to use these or use Azure's built-in Azure Log Analytics and Azure Application Insights. These monitor app telemetry and use machine learning to provide deeper insights and diagnostics into your apps and workloads over their entire lifecycle. Lastly, if you use AWS Trusted Advisor for proactive resource optimization, you can take advantage of Azure Advisor at no additional cost. So that was a brief overview of how the fundamentals of AWS translate to the Azure platform. I hope it helps you to see how you can start to apply your existing AWS skill set when working with Azure. For more extensive hands-on learning, please check out the following links.